Hey everyone, and today I'm going to be showing you a most definitely wrong method to estimate log base 10 of 9, and specifically just log base 10 of 9, given that log base 3 of 9 is 2. So the first thing we want to do is rewrite this equation. Both equations actually. So we'll have 10 to the power of whatever equals 9, we don't know what that is. We know that 3 squared is 9. Now, we want to establish a couple things first. So I'll establish that the base is x. We refer to that as x. Our exponent is y. And the result of the function is z. So we're looking to find dy, or the change in y. Change in y given the changes in x. So the way I did this, and it's definitely wrong, but we'll do it anyway. We want the equation y minus 2. So we're subtracting y values here. And we want 10 minus 3. So we're subtracting base. And all of this equals 9. Now normally, you could just solve out for y, no problem. But in this instance, multiplying 10 minus 3 to the denominator side is not what I'm going to be doing. Instead, I'm going to be multiplying it on the numerator side. So we get 10y minus 3y minus 20 plus 6 equals 9. Now we can simplify this equation down a bit, so we get 7y, and then that's what, minus 14 equals 9. From here, we can actually solve for y. We get 7y equals 23. Now this is where things get a little different. Instead of simply solving out for y, we're going to use modular arithmetic to find the remainder of y, and I'll show you guys why I do that. So in the mod 7 world, let's do this up here, we would get 3, r equals 2, r for remainder, and this is mod 7. This is modular arithmetic. So now that we have 3, we can write the new equation, or fraction, 3 over 10 to the power of 2. We take our remainder and square it. Or use it as the exponent to square our base of 10. So this gets us 3 over 100, which equals 0.03. Now, we know we're looking for what the exponent will be to make 10 to the power of what equal 9. We know that log base 10 of 10 is 1, so we're only going 1 down in terms of z. The change in z is just 1. So we can do this here. We'll do 1 minus 0.03. That gets us 0.97. So we can say that dy is approximately 0.97. Now we can do this in a calculator, obviously. This is what I would recommend. It's just a lot easier. We do log base 10. We see that's 0.9542. We were pretty close to estimating this log, but you have to break so many. You're probably breaking a lot of rules when you do this. Not only that, this doesn't work for every log. It just so happens to work specifically for log base 10 of 9, given that log base 3 of 9 is 2. So this is a fun, but most definitely wrong way to estimate logs, specifically this log. Thank you for watching.